In this video, I'm going to explain you the basic operations of Pandas module in Python. For the Pandas module, I'm going to use the Google Colab as my IDE. But you can use any IDE that is available to you. It can be Visual Studio, PyCharm, or Jupyter Notebook. Your wish. The results will be same no matter what. So let me open my IDE first. For that, let's go to my Chrome browser right now. Let's start my Chrome browser. Now let's get into my work. Now let me open my drive first. So before I start, I have already created a Pandas Google Colab file in which I have written all the basic operations of Pandas to explain everything in the most efficient way. So now let me open my Python Google Colab file that contains all the Pandas operations that you need. Here is how a Google Colab starts. It's loading right now. Yeah, it has been loaded. Now as the Google Colab has been loaded, now you have to connect to a runtime in order to run the cells below. Now the Google Colab has been connected to a new runtime. So let's get started with the first cell. In the first cell I have imported Pandas module, stored it in a variable p. Similarly I have imported NumPy module, stored it in a variable n. Then I have used series function in Pandas module, p.series of I have generated 5 random numbers using NumPy module like n.random.random of 5, which generates 5 random numbers. And then I have given index to these random numbers, and the index I have given is nothing but 5 alphabets. So the series will be generated having the index as these 5 alphabets, and the series length would be 5 as I have generated only 5 numbers. So in Pandas module you can generate the series like this. Here you can use the random module from NumPy to generate random numbers. It can be rand int, rand n, or either you can directly write the numbers you would want. So let me run this cell for you first. Yeah, as you can see, the series will be generated like this. The series will have the index which we have given. Now let us give a specific set of numbers. Let me take 1, 2, 3, 4, 5, and now let me run this cell for you again. Yeah, as you can see, here you can take a list of specific numbers you want, or you can generate random numbers using NumPy module. The random numbers can be generated using random module, and in the random module you can either use rand int for integers or rand n for random numbers. Now let's move on to the second cell. In the second cell I have taken a dictionary. Here A, B and F are the keywords, and 1, 322, 344, 54 are the key values. Now a series can be generated using this dictionary. Now I just have to use p.series of E, which is the dictionary, and a series will be created. Let me show you how this works. As you can see, the keywords became the indices and key values became the series. Now let's move on to the third cell. In the third cell I have created a series containing 10 random numbers. I have created a series using Pandas module p.series of n.random.random of 10, which creates 10 random numbers using random function in random module, which is in NumPy. Let me run this cell for you. As you can see, 10 random numbers are generated and stored in a series, and the index of the series is by default started with 0, and according to the number of elements it will go on. Here you can also see I have used a print function here but in the above cell I have not used any print function. So now let me tell you why I have done this. You can either use the print function or just ignore it while using the Google Colab or Jupyter Notebook, because these two notebooks are highly advanced and they don't need a print function for the display of output. Now let's move on to the fourth cell. In the fourth cell I have used ilog function. I have taken a variable u and I've used ilog function. Let me tell you what it is. L dot ilog of 0. We already know that L is a series that I have created using a Pandas module, and now I'm using ilog function on that series. Whenever you see this square bracket, the index is involved in it, and L dot ilog of 0 is nothing but 0 index element, or the 0 index element is this one in the series I have taken. If it is 1, it will be this element, 1 index element, 2 index element. It depends on the index. And for this one, I have used print function. You can either use it or not. It is your wish. Let me run the cell. As you can see, 0 index element has been printed out because of ilog function. And using this series, I'm going to explain about ilog function furthermore, so stay tuned. Ilog function can be used in the series and also in data frames. Moving on to the fifth cell, I have used ilog function again, and now I have used a colon, and the colon is used to slice any list, and here I have sliced this series instead of a list. So as you can see, I used L dot ilog of colon of 5. So it has sliced the 5 elements starting from 0 index to 4 index. So the 5 index element will not be printed out because it will only print 5 elements from 0 to 4. So let me run this cell in order to get the output. So as you can see, 0 to 4 index elements are printed out, and it has sliced the 5 elements in the series. Now let me write 6 here. Yeah, as you can see, it has sliced 6 elements. Let me take 7. It will slice 7 elements. 4 colon 7. Then it will start with 4 and end before 7, containing only 3 elements. Let me show you this. So as you can see, it has started at 4 and it ended before 7, containing only 3 elements. So the slice will always start at the starting index and end before the ending element. If I take nothing here, it will start by default at 0 because there is nothing in here. If I take 3 here, it will start at 3 and end before the last element of the slice. Let me show this. Yeah, it has started at 3 and ended before the last element of the slice. Last element of the slice was 7 here, and it is ended at 6. Now let's move on to the fifth cell. In the fifth cell, I have taken a variable k and I have used the square brackets again, but in the square brackets I have used a logic, and this logic is L is less than L dot mean. So the L dot mean is nothing but the mean of all the elements present in this series. So now here I have requested the elements which are less than the mean of the series. So mean of the series will be something. We can also print that. Now let me show you what is the mean of the series. For that I'll take m is equals to L dot mean. Now I'm going to print the m. Let me run this cell for you. As you can see, the mean has been printed out, and the mean of series is 0.087. So in the above variable k, I have requested the elements which are less than the mean. The elements which are less than 0.087 that are present in series L. Let's see what elements are less than 0.087 in the series L. The first element is less than 0.087, the second element is greater, the third element is greater, but the fourth element is less. Fifth element is also less than 0.087. Sixth is not, seventh is less than 0.087, eighth is not, the ninth is less than 0.087, and the 10th element is greater than 0.087, and that's it. As you can see, the output is also what we have predicted. We have predicted around 5 elements that are less than 0.087, and that is what has been printed out as output. So you can use any logic here. It can be greater than, it can be equal to, it can be anything. You can even use arithmetic logic, you can even use calculus, you can use anything that you would want in this space and get the required elements in the series. I have showed an example and you can practice it. Now let's move on to the 7th cell. In the 7th cell, I have used a variable pp. In pp, I have taken alloc function again. In that alloc function, I have taken a list of numbers, and that numbers are 1, 2, and 3. So when you take list of numbers in alloc function, it will print the respective index elements of those numbers present in the list you given. It will print the index 1 element, index 2 element, and index 3 element because we have taken a list in it. So let me tell you what those elements are right now. The index 1 element is this, index 2 element is this, and index 3 element is this. So because I have taken a list of numbers and those numbers match with the index of the series L, so that is why alloc function will give output as the elements to respective indices of the numbers we have used in the list in the alloc function. Let me run this cell for you in order to show you the output. As you can see, the elements I have showed you before are outputs. Now let's move on to the 8th cell. In the 8th cell, I have taken a variable ps, and in ps, I have taken exponential power of pp. And in pp, there are 3 values. So ps will also contain 3 values, and those values will be the e to the power of values of pp. And I have taken another variable pss, and pss contains logarithmic values of pp. So now let me write a print function, or I'll just show you how Google Colab or Jupyter Notebook will give the output without using a print function. Let me take ps first as it is and run this cell for you. Yeah, as you can see, 3 values are generated, and these 3 values are nothing but the e to the power of these values. Now let me take PSS and show you the output. As you can see, the output has been printed out, and again the 3 values are obtained, and first 2 values are nothing but logarithmic values of these 2, and the third value is none because logarithm never takes negative value. Let's move on to the 9th cell. In the 9th cell, I have taken a variable OL, and OL is nothing but sum of L plus L. Let me run this cell for you. Yeah, as you can see, it has been printed out. So the output series OL will contain elements which are double of elements containing in L, because OL is nothing but L plus L. You can cross verify this because in the original series L, the first element is minus 0.164, and double of minus 0.164 will be minus 0.328. Yeah, as you can see, it is minus 0.328. and you can cross verify all the elements. Here you can see the series. As we generated 10 random numbers and 10 random numbers were generated, but index was started with 0. So now let me tell you, if I take iLock, it will act and calculate depending upon the index. But if I take normally square brackets behind any series, it will act as the serial number. Moving on to the 10th cell. In the 10th cell, I have taken L of 9 is equal to 20. L of 9 I have taken in square brackets, and I have not used any iLock function. Because of that, the square brackets will act as just serial number indicators. Means without iLock function, I have taken square brackets of 9. That would represent the 10th element or serial number 9 element of the series L. And in this line, I have overwritten and changed it to 20. Previously, it was 1.660567, but I have overwritten it to 20. Means I have changed it to 20. Now let me print the series L again. As you can see, the serial number 9 element is changed to 20. While overwriting any values or changing any values, we always take the normal square brackets behind the series L, or any series you take depending upon the series and the series name. We just take square brackets behind the series and use the serial numbers to change or overwrite the elements. Moving on to 11th cell. In the 11th cell, I have taken a variable OP, which is L plus L. L here is this series, as I modified or changed the value of 9th serial number element or 10th element. Let me show you the output of OP. Yeah, as you can see, L plus L is double of L, and you can verify this by 9th serial element or 10th element here. 20 is the L value, and OP value is 40, and OP is double of L, and you can verify this. You can take any values, it's your choice. Moving on to 12th cell. In the 12th cell, I have taken a variable OI. In the OI, I have added L of 1 colon plus L of colon minus 1. As you can see, I have printed L of 1 colon, which is this one, and the slice is started from 1 to the end of the series. And I have also printed L of colon minus 1, which is this one, and here I started the slice at 0 index element and ended it with last but one element. Whenever I take negative numbers at the second half of the colon, it will remove those many elements from the end of the series. You can remember like this. And I have also printed out the output of OI, and you can see this. This is the output of OI, which contains the first element and the last element as none, because here the first element is absent and here the last element is absent. So in this case, the first element is added to nothing, and here the last element is added to nothing. That is why here you get nothing as first and last elements, because adding absent data row and a data row will give you none as output in that specific row.